Your MCP server runs perfectly on your machine, but recreating that exact environment, dependencies, Python version, even the entry point, somewhere else still means digging through docs or guessing at JSON structure. We'll use a declarative fastmcp JSON that pins everything. The server file and its MCP entry point as required fields, optional dependencies like pandas, or a full requirements, TXT, Python version constraints, and even deployment settings like transport method or log level, all validated by the schema reference so your IDE catches typos before runtime. One file, 0, works on my machine surprises, and full compatibility with Claude Desktop, VS Code, or any MCP client.
Schema, https://gofastung.com/public/schemas/fastmcp JSON/v1 JSON. Source, path, server pi. Entry point, MCP. Environment, dependencies, pandas, matplotlib, Seaborn.
This demonstrates the standardized server configuration pattern using fastmcp's JSON schema. The configuration defines a complete portable server specification through required source declaration and optional environment and deployment sections. The distinctive aspect is its schema-backed structure that enables IDE validation while remaining flexible enough to handle everything from simple scripts to production deployments. The pattern works by separating concerns into 3 logical layers: source, what runs, environment, how it runs, and deployment, where it runs. The source section is mandatory and points to the executable code, while environment handles dependencies, Python versions, and runtime variables with interpolation support. Deployment becomes optional but powerful, controlling transport protocols, logging levels, and execution context. This hierarchical approach allows progressive complexity. Simple scripts need only source, while production systems can specify every runtime detail. This approach eliminates environment-specific deployment issues by making all assumptions explicit and machine-readable. Teams benefit from consistent behavior across development, staging, and production, while the schema validation prevents configuration errors early. The trade-off of initial setup complexity pays dividends in reduced debugging time and seamless client integration, whether that's local development tools or cloud deployment systems. The configuration's portability means the same file works across Claude Desktop, VS Code, Cursor, and CI/CD pipelines without modification. Let's break it down line by line. This defines a fastmcp configuration file using JSON schema validation. The required source field specifies the entry point, server, PyMCP, while optional sections like environment declare dependencies or reference requirements files, deployment configures transport protocols and logging, and Python pins version requirements. The schema reference enables IDE autocomplete and validation, with version-specific URLs ensuring compatibility. Environment variables support interpolation, and all fields have sensible defaults, file system source type, UV environment manager. This pattern solves works on my machine problems by explicitly declaring runtime requirements separate from implementation.
Schema, https://gofastung.com/public/schemas/fastmcp JSON/v1 JSON.
The schema reference links this config to fastmcp's official JSON schema, enabling IDE auto-completion, real-time validation, and error highlighting. It uses versioned URLs to prevent breaking changes, with modern IDEs providing inline documentation and suggestions as you type. This declarative pattern standardizes configuration while allowing optional sections like environment for Python version and dependencies, and deployment for transport settings and log levels. The source key declares your tool's executable entry point in fastmcp's configuration. It's the only required top-level field, specifying the module path and which function, entry point, handles execution. Optional type field defaults to file system, but supports alternatives like Git for remote sources. This follows fastmcp's declarative configuration pattern, where runtime behavior is defined in JSON, not code, enabling consistent execution across environments, while supporting version control and IDE validation through the schema reference. Modern IDEs use this schema for autocomplete and validation, with version-specific URLs ensuring compatibility.
Path server pi.
Specifies the server module path in fastmcp's declarative configuration. This required field points to the Python file containing your @MCP tool decorated functions, while the optional type field default. File system defines how the path is resolved. The configuration follows JSON schema validation via the schema reference, enabling IDE autocomplete and pre-deployment validation.
Entry point MCP.
The entry point field declares the root handler symbol fastmcp loads from server pi. This becomes the central dispatch point for all AI tool calls, with the schema validating that MCP exists as either a function, class, or module. Required when source path is specified, it enables the framework to bootstrap your tool implementation while maintaining clean separation between configuration and code. The pattern mirrors Python's main convention, but for MCP services, ensuring consistent startup behavior across development, staging, and production environments. Modern IDEs use the schema reference to validate this structure, providing autocomplete for entry point, type, and other optional fields like Python version in the environment section. This closing brace terminates the root configuration object, completing the fastmcp JSON schema definition. It maintains valid JSON structure while keeping all sections optional except source, which requires either path or entry point. The schema reference enables IDE validation with autocomplete, supporting both version-specific and latest schema URLs. Modern IDEs use this to validate fields like optional type, defaulting to file system for source, UV for environment, Python version specification, and the deployment section, which handles transport and log-level configurations.
Environment.
The environment key declares optional runtime requirements and configuration for the fastmcp tool. It supports direct package dependencies, Python version constraints, or requirements files, with environment variables properly interpolated at runtime. This section works alongside the optional deployment key, which handles transport settings and log levels, while the required source key defines the entry point using either file system paths or remote transports.
Dependencies, pandas, matplotlib, seaborn.
This specifies the Python packages needed for execution, using fastmcp's declarative dependency management. The environment section is optional, but when present lets you pin Python versions, specify transport methods, and set log levels, all while supporting requirements files or direct package lists. Modern IDEs leverage the schema reference for validation and autocomplete, ensuring configuration correctness across dev, test, and production environments. This closing brace terminates the root JSON object, completing the fastmcp configuration. It finalizes the optional environment block and required source definition, ensuring valid JSON structure that modern IDEs can validate against the schema reference for autocomplete and error checking. The configuration follows fastmcp's declarative pattern, where only the source field is mandatory, while environment and deployment sections remain optional for specifying Python versions, transport methods, log levels, and either direct dependencies or requirements files. This pattern enables environment-specific configurations and smooth CLI migrations, while defeating works on my machine problems through explicit, version-controlled settings. This closing brace terminates the root JSON configuration object for fastmcp. It finalizes a declarative configuration that requires only the source field, but optionally supports environment and deployment sections, with the schema reference enabling IDE validation and autocomplete for fields like type, Python version, transport, and log level. The configuration pattern solves environment-specific issues by supporting requirements files or direct dependencies, Python version pinning, environment variable interpolation, and transport options, all while maintaining portability across development, testing, and production environments. Declarative configuration. fastmcp's JSON schema transforms runtime settings into versioned, environment-aware declarations where only the source field is mandatory. The optional environment and deployment sections let you specify Python versions, dependency management via direct packages or requirements files, and runtime behavior like transport protocols and log levels, all validated by your IDE when the schema reference is present. Omitting the type field's defaults to file system for source and UV for environment, while undefined environment variables using varname. Interpolation will raise clear errors at runtime, not fail silently.
The schema that validates the configuration becomes invisible the moment it works perfectly.